Welcome back to Inside Assemble AI, and welcome to our Season 1 finale. I'm Sam, and alongside my co-host Mac, we have spent this entire first season exploring how artificial intelligence is transforming business strategy and innovation across every sector imaginable. From AI in marketing and education to executive leadership and community building, we have cut through the hype to bring you real insights from leaders who are implementing AI strategically in their organizations. Today, we are closing out our first session with what might be our most exciting topic yet, the convergence of AI and robotics, and how this powerful combination is reshaping everything from disaster response to space exploration to the factory floors and homes of tomorrow. We're asking the big questions. How is AI enabling robots to think, adapt, and operate in ways we never thought possible? And what does this mean for our future, both the incredible opportunities and the challenges we need to navigate responsibly?
Our season finale episode is called AI and Robotics, the Future of Intelligent Automation. And we are diving deep into the technical breakthroughs, real world applications, and ethical considerations shaping this rapidly evolving field. Today, we are joined by Daniel Richey, a veteran technologist and founding member of Brainwave Collective, where he explores the intersection of AI, robotics, and advanced emerging technologies. With over 15 years of experience in DevOps, software integration, and system design, Daniel brings a technical perspective grounded in hands-on experimentation and performance. He's competed in judge numerous hackathons internationally, including events hosted by Hugging Face, NVIDIA, and Meta, often earning top honors for novel applications of AI in hardware and software systems. His recent work includes contributions to open source AI tools, networked robotics, and agentic video frameworks. Daniel's experience spans both large-scale enterprise environments and fast-moving prototype environments, giving him a unique lens on how to quickly evaluate technical feasibility, test ideas, and iterate toward viable product concepts. Daniel, we are thrilled to have you here for our season finale to explore this fascinating intersection of AI and robotics. Welcome.
Thank you, Mac and Sam. It's an honor.
Thanks, Daniel. So let's start with the big question. How do you see the relationship between AI and robotics evolving today? Are they developing in sync, or is one advancing more rapidly than the other?
I think that AI has certainly been an accelerant for robotics, and especially in recent years, both for capabilities and also for the reduction of cost and the accessibility of these platforms. A project that will come up a few times today, I'm sure, is Hugging Face's Lay Robot, but you also have NVIDIA's platform, which covers a variety of aspects, simulation, model, and ultimately it means that more of us can participate. It will be less expensive to do so, and the robots themselves will be more capable.
Fascinating. Moving to the next question. You've been deeply involved in hackathons and cutting edge development with the community. What's one recent breakthrough in AI powered robotics that really excited you, and why?
This is, I'll play on this for Hugging Face's Lay Robot project as well as NVIDIA's one group model. One of the most exciting things, we hosted a hackathon, I guess it was just a month ago now, a little more than a month ago. And we were working on this open source project. Anybody could 3D print the parts in a weekend. You have to order some supplies from overseas. But assembling the robot only takes a few hours from you have no idea what you're doing to being able to put this robot together. So having a low-cost robot that anyone can participate in is really exciting because this used to cost many thousands of dollars, in some cases tens of thousands of dollars. And in the last couple of years, that's dropped to just a few $100s. And I think the most exciting advancement was the release of NVIDIA's open source model, which was very, very capable, very powerful, quite small, only 1.5 million parameters. And 3 weeks after they released this groundbreaking model, they released a tutorial on how to post-train with this very inexpensive robotics platform. So you have the most advanced companies really building at the bleeding edge. But just within weeks of release of the research, you also have instructions and the guides and everything necessary for you at home to do this. That's 3 weeks to go from emerging research to anyone being able to approach and access this. And I think, I don't know how I would describe it exactly, but this idea that we have bleeding edge research that previously was locked behind the labs of well-funded institutions and experts that had a depth of experience in the field. And now anyone in a few days for a few $100s can access really the latest in what's happening.
No, that's fascinating. And I think that's kind of like reemphasize the idea of open source model, due to the open source model and also that robots being cheaper than it used to be, it's literally helping this robotics fill the industry, progressing further. So just kind of going back to what you said earlier, that AI is also powering the robotics industry. It's kind of like going hands in hand, and both of them are mutually benefited from each other in this journey. So thanks, Daniel, for your perspective on that. And for the next segment, a real world AI robotics application section, I'm going to pass it over to Mac.
Thanks, Sam. Daniel, thank you so much for the explanation. So what I came to know from you that right now it's so easy to, if someone has genuine interest in robotics, then like from just in idea phase to executions, in just in a matter of couple of weeks, 3 to 4 weeks, I think like someone can assemble a robot. I mean, that's actually a game changing thing. Even 3 years back, that we didn't even think of it, right? I mean, we're in that phase right now that once someone can literally build a robot. I mean, that's a great thing. I mean, and that's the technology advancement that we have right now. So my next question to you, so I'm going to talk about now, it's more of the real world AI robotics applications. So let's get into the practical applications. So can you walk us through a real world robotics project that successfully integrates AI in a meaningful way? And I am particularly curious about your journey conducting the recent AI hackathon in partnership with Hugging Face.
I'll bring both of these together. I'll highlight a real world project that was one of our participants, one of our competitors in that competition. So the idea was you have a robotic arm that is capable of being controlled by an AI brain. And if you listen to people having conversations in the industry today, they talk about AI robotics being basically two pieces. You have the physical robot itself, and that's a whole domain where you're developing the physical bodies of these robots. And then you also have the brains of the robot, the AI that's thinking about the movement of that physical robot. So if you have that ability and you can tie in other unrelated aspects of AI, such as computer vision, you can utilize the ability to decipher what a camera can see, to process that information, and then to have the robot act physically on that. So one of our competitors had an idea of diverting recyclables from a waste stream. So you have a conveyor belt full of trash, but some of that trash is reusable, it's recyclable. So instead of sending it to a dump, if you could say pick out parts that could be recycled or reused and divert them to other areas, you would improve the whole of our experience. So the idea was you had a camera that was that had a system that was trained to identify recyclable material versus waste. And when it identified a recyclable item, it could then reach in, grab that recyclable item from that waste stream and divert it to be reused. And this was a high school student who had never trained an AI model before. They had never interacted with robotics before. And in that one weekend, the whole event was maybe 30 hours. They went from a pile of parts to assembling this arm, to going home and overnight training a system to identify those recyclables, and then to have the robot then understand how it could pick up those items and divert it from waste and prevent it from just going into the landfill.
Amazing. That's great.
Great. Yeah. And what was your experience with, your hackathon partnership with Hugging Face? If you can just elaborate a little bit.
I think Hugging Face is such a unique company, and they're so important for where we are today in machine learning and AI. They're the GitHub of AI models and data sets, and they don't just talk about doing interesting things. They actually invest in releasing projects that are ultimately useful. And this project has a 3D printed physical arm, which I have here. I'll show you the arm here. Okay. So the way you control this is you open and close the jaws of the robot like this. And then there's another robot that responds to the motion of this robot. Well, this was designed by a world-class robotics designer. It's open source. You can 3D print it in a couple of days on a readily available commodity printer. You don't need a special printer. It's just a few dollars worth of plastic. You can order all the parts from a list that they provide, and then you can assemble this on your own. Well, the only reason all of that came together, and the software was also provided to control this and record the training set and everything else, that was entirely because of Hugging Face. So they made all of this available and accessible because they wanted to make robotics more approachable for everyone. And probably this wouldn't have happened in this way without Hugging Face's involvement. So to celebrate a new design that they had, a new design iteration of this physical robotic arm, they hosted a worldwide hackathon. They had over 100 cities that participated, thousands of participants, and they let different individuals host locally. So Denver was one of those 100 cities, and we did it right here in Denver, Colorado, and had people come together, learn how to build this physical robot, learn how to train it. And Hugging Face was just fun. It felt like we were working with friends and having a good time, exploring new technologies and learning something that was exciting and interesting. I mean, none of us know what we're doing. It's too new for anyone to know what they're doing. So to have partners to share and explore and chase down whatever's coming next is just an exciting thing. So we're very thankful that they put this event on and allowed us to participate, supported us as well.
Daniel, both of your examples are very fascinating. The first one was to differentiate the recycle from the waste stream, and the second one is creating a robot. It's a very short time, and like through Hugging Face for all these things. So can you walk me through, like, let's say if I want to create a robot to do my landscaping stuff to my home, then what will be the initial step? Let's say I do not know anything at all, right? I'm totally novice and I don't know anything at all. So from start to finish, can you walk me through that? What are the steps, and like how even I can learn from Hugging Face the models, and then just on a very high level.
Yes. So I'm going to describe this in two ways. I think one is you're a curious individual who wants to understand how all this works and get your hands dirty and get involved, even if you don't have a depth of related experience. And then the other aspect would be, say, if you're a company that's developing a product or a service, maybe a solution that you would provide to the marketplace to do your landscaping, right? So there's a difference between the commercialization of these applications and understanding the raw kind of foundational pieces that bring all of this together. Okay. So I'll start with the individual aspect. Or I'm sorry, was there another question? No. So I'll start with the individual aspects of this. Let's say you've never done anything with robotics before, and you heard about Hugging Face's open source robotics project. What would it look like for you to walk through that process? Well, the first thing is you would need to download the model or find someone that has a 3D printer and is willing to 3D print the model for you. This takes a couple of days for the prints to run. And then you have a pile of parts. You'll spend an afternoon assembling those plastic parts, and you'll have to include the electronics, the motors that control the movement of the robot itself. And all of that costs you a few $100s in a weekend if you do it yourself. Now you have a physical robot. Well, you have to understand how to move that robot, how to control that robot. And that's where Hugging Face's LaRobot comes in. It's a framework that has all of the software for understanding the movements and controlling the movements, but it also allows you to record the data for the task at hand. So let's say that you want to pull weeds out of your landscaping. In the same way that you have a camera that can identify recycling versus trash, you would have a camera that could identify a good plant versus a weed. And maybe a third party would provide that to you. There'd be a service, a plant identification service, where you'd send an image from your camera up to some company and they would tell you, yes, that's a weed, you should pull that out, or don't touch that, that's a good plant that you want to keep. Or you could learn how to train a model, fine tune a model yourself, and you could actually use the open source AI that's available from Hugging Face. And you could train your plants in your garden to identify what was weeds versus what was not. Now, that's a much deeper, more involved task, but it's possible for you to consider going down that road. And then you have the movement of the robot as well. Well, I showed you the robot earlier that is a handle that you can move around. What that allows you to do is it allows you to move the robot the way that you want to move it, and you record that movement. And then you tell the AI, based on what we can see, this is the movement that I want you to do. And it can learn from you. So you're actually physically moving the robot the way that you want it to move. And then it can understand that and learn from that. So that's kind of the introductory aspect of this. And you can take it as far as you want and go as deep as you want. You could train your own model based on your entire yard. You could put your robot on wheels so that it could travel around the yard for you and do these different things. And that's if you're doing it yourself. Now, taking that to a commercial application, there's many other steps involved in that. And if you maybe aren't as interested in doing it yourself and you want to leverage models that are or solutions that are already out there, we have more generalized models that are coming out where you can even ask the model to do something for you. So you might have text that says, remove the weed from the garden, and it will understand that text and know how to translate that text into the movement of the robot. Some of these things are becoming available at a research level today. And without question, we will see many companies that offer commercial solutions that will do these types of things for you. It's kind of to be seen if they will make it available directly to us, or if they will offer a product where it's an entire robot kit that will do weeding for you and you must go through their proprietary system in its entirety. But all of these things are going to be available. We're going to see everything from that raw open research all the way up to proprietary models and even proprietary complete systems that perform a specific task that you will purchase that for.
Wow, that's a great way to explain things. I mean, I really learned so many things. I mean, just on your explanation. So this just came to my mind, that I literally spend every weekend almost a couple of hours sometimes, or maybe twice in a month at least, just to pick up the for the weeds from my grass. And I have a big lawn and backyard. So definitely, I mean, that is something that probably maybe, I mean, I could have tried. Thank you so much for your explanation.
You can always invite Daniel to your place and Daniel will build a robot for you.
There will be many people doing these tasks to teach the robots how to do them before we have the robots doing them. Yes.
Okay. And even before going to the next segment, I have just one more question. So let's say, how is enabling robots to adapt to unstructured or unpredictable environments like disaster zones, outer space, or dynamic factory floors? What makes the difference between a traditional robot and an AI-powered one in these scenarios like that?
Oh my gosh. So I think what's important for the audience to understand is in traditional robotics, there is an unbelievable amount of work that goes into the motions and the movements of the robot. And the amount of training, even if you have AI and some of these kind of record and playback types of approaches that are helping, the movements are very, very complicated to get right and to act in the way that you want them to act. And if anything changes, even the slightest amount, if something changes, it can really be problematic. I'll give you a real example of this. With the new models that have vision and can see there's a scene that it can see and interact with. If you record that with sunlight and the time of day changes, the changing of the angle of the sun or the introduction of new shadows can be enough to completely break the model. So you need a robustness to go into, say, a disaster setting where you have no idea what you're going to encounter. And you're not going to get that robustness from, we'll call it, lesser models that are even available today. But if you go back to robotics just a few years ago, the idea that the robot could understand the scenery and recognize how to respond with an arm that might reach out and do something, let alone wheels that would have to climb over rubble that was strangely shaped or maybe slippery or whatever it might be. These are really, really hard challenges. But just in the last few months, we've seen some unbelievable advancements that are allowing these physical robots, which are AI enabled, to respond to environments in ways that have never been seen before. It no longer is requiring these extremely structured, expected environments. We're now starting to see robots that can respond to unexpected situations. If they're picking up an object and moving it to another destination, that object can be oriented differently. It can be in a slightly different location, and it can understand, I need to move a little bit to pick this up and make it happen. So this physical intelligence that is being added into the robot is something that has a really dramatic effect on the types of things that we're able to do. And just a few years ago, this was dreamy to think about the possibility of having a robotic system that could sense and respond to uncertainty.
Awesome. Really appreciate that the way you explained. And for the next segment, for technical foundations and challenges, I'm going to pass it over to Sam.
Yeah, thanks, Mac. And Daniel, my next question is kind of piggyback on what you mentioned about the image classification part. So, if I go back to like 5, 6 years back, I guess you could probably see my computer vision book over there. So we used to live in a world of YOLO, like you only look once. The image classification like ImageNet or all kind of models like Dr. Fei Li kind of like started in her Stanford lab, I guess. So now if you move to the robotics transition part, like so what role these techniques like reinforcement learning, computer vision play, or image classification play in the modern robotic system? Is it kind of like the same the way we've seen computer vision through the lens of a computer, kind of like play the same way when a robot utilizing those same computer vision model and kind of like trying to do the image classification or categorization or even object detection in a dumpster or in a trash where they're trying to find the recycle items. So how that's that parallel,
Yes, absolutely. I've got great answers for you here because the recycling the trash computer vision was actually YOLO is what they used to do that.
Okay.
And also Le Robot for managing the video feed actually uses ResNet. And so we always love to hear references to Dr. Fei Li. So it's certainly all of these things are not like this sudden burst of an invention that someone just came up with overnight that is wildly different from what we've known. It's truly building upon things that have taken decades to put into place and understand well. And that barrier to entry is just so much lower, right? The idea of, our friend, the high school student who did that project, the idea of someone who had never done computer vision before, who had never trained a model before or fine-tuned a model, who had never done anything with robotics, to go from literally nothing to have a model that they had trained overnight in basically 24 hours. Like you can't even imagine someone being able to do that 5 years ago, right? So the barrier to being able to do these exceptionally powerful things is just so low. It's such a ease of access and ability to do some really incredible things, and it's all built on the shoulders of giants, these luminaries and others who have spent decades building foundations for us to be able to do these things today.
Yeah, no, it's fascinating, seeing this progress, especially as you mentioned that computational power, it's not seems like a bottleneck anymore. Like somebody can even just train the model overnight with the limited resources they have, which is really a great progress that we made in the computational world, especially in terms of computer vision.
Yes.
Uh, I think but like still we always take things in a grain of salt, especially when it comes to technological innovation. There's always a room for improvement, right? So keeping that in mind, what are the key challenges or limitations holding back wider adoption of intelligent robots in home, healthcare, or industry? I'm not talking about Tesla robot because they're very expensive. That's coming out probably next few months. But in your opinion, what do you think that's going to still hold us back to implement that at large scale in household?
Oh my gosh. I think I've given Hugging Face and the Robot project a lot of airtime, and I'm going to keep doing that. They understood, I think, at least as far as I can tell, earlier than anyone else, that there was this opportunity to bring this technology to the masses. And that's why they put this project together. You mentioned Tesla. One of the people that's involved in that project came from the Tesla humanoid project. And they're now creating these robots and these processes that make it available for us to interact directly with. So we're seeing this incredible confluence of not only these platforms becoming extremely inexpensive, but
Mhm.
also simplified in a way that almost anyone can access this. I'm not exaggerating when I say this. If you create a Hugging Face account, run run a pip install, and set up your environment and run a pip install, and run something like 6 Python commands, you'll have created a data set that you can then use to fine tune a robotics model, right? And nobody bothered putting together something like that to make it easy for everyone to access. Now, it's still a little bit of a technical challenge. But when you reduce that barrier, you now have people who maybe are traditional technologists, or even people who are curious and are maybe ambitious enough to try to say, I can fumble through this and figure this out, or even more traditional robotics people who are involved in the physical side but want to kind of dip their toes into the AI and machine learning of all of this. So you have, we'll call it the non-industry, the non-technical, right, non-machine learning people getting involved in all of this. And it's very inexpensive and it's very approachable. So that's one piece of it. In addition to that, you have NVIDIA releasing the latest and greatest in world-class robotics movement models. And then 3 weeks later, providing everything necessary to apply that model to this same platform. So what used to be this massive, massive gap between industry and research and everybody else is now this very, very narrow gap. You need a few $100s in a weekend and an awful lot of curiosity, and you're sitting at the table with everybody else that's doing all of this at the same time. You mentioned reinforcement learning. There's new techniques that are coming out. There's new research that's coming out. There was a small visual language action model that Hugging Face put together. And the entire thing, this runs on commodity hardware. So, your laptop can run a visual language. Your camera can identify what's in the scene and you can say, hey, robot, go pick that weed for me. And it will do that. They trained that entirely on community data. What I mean by community data is those 6 Python commands that I talked about, being able to record that data set. Well, if you saved that publicly to Hugging Face over the last year, that was used to create this industry novel model that could run visual language on a laptop. That could have been your data from just somebody that was curious about robotics on a random weekend. So narrowing this gap on the technical side of things, where you have the actual implementation and the learning and everything else, you're going to create people who understand these things in a way that allows them to get their first job in robotics. No longer do you have to have an advanced degree in robotics to be valuable for a company that might want to implement some of these things. And undoubtedly, we're going to have companies that create platforms that make it easy for workers to access all of this. So you'll need people who understand how to interact with this on a basic level. So as the price comes down, as the availability comes down, as these more advanced opportunities are more widely available and accessible, we're going to have these things just become part of our daily lives. And I think I have to credit Jensen Huang for this, but everything that moves will be automated with robotics, is where the target for this is. So the opportunities that exist, the only reason it hasn't been done yet is because it's not easy enough or it's not cheap enough. And things are becoming very easy and very cheap, even for the most advanced of the technologies that are out there.
Yeah, no, love that, Daniel. It seems like as the price is going down for all these hardwares and even you have easy access to all the LLM models that you can even like run on your local computer. You don't even like a computer degree or probably like a high advanced robotics degree. I think at the end of the day, just to back to that question, I think the main challenge and limitation is that how much you're curious to learn about robotics and want to develop it. I think that's probably something that's going to hold us back in future. I guess technology won't be a limitation anymore. And also it will probably be cheaper than it used to be back in the days to build your robot or something only an enterprise company can do. But now everybody can do probably in their backyard or in garage space. Yeah, that's great. Thanks, Daniel. I'm pretty sure our listeners are really interested to know more about the robotic stuff, and we have a few more questions to cover. Before I move to the jump to the next section, the last question I do have for this one is that you mentioned about some of the technical hurdles that you've seen while you guys are working on the hackathon and stuff. And I know there are like high school kids like literally went back came home, trained the model overnight and came back next morning and probably built that robot by itself. So in that particular, going through the experience, is there any sort of like a technical hurdles that high school kid or any other attendees face while going through the hackathon event? Because I'm pretty sure some of our listeners would love to now go back to their home office, maybe try hands-on or, so what are the tips you can share with them, especially the technical issues people face during the hackathon event that you can share with our listeners?
Absolutely. We had everyone from, people who had never, high school students who had never done anything with robotics before, all the way up to people who had, who were serial entrepreneurs that launched robotics companies. So there's a breadth of experience that participated in these types of events. And I think if you were trying to do this on your own, there's a broad range of domains that have to come together to make all of this make sense. And none of it is very difficult, or at least for the Robot project, none of it is very difficult. But it covers a lot of ground. You have the physical robots. You have to, pick up a screwdriver and put it together. Right? You literally have to assemble it and 3D print it. Not everyone has that knowledge, or they're maybe they have a screwdriver buried in their junk drawer at home or something like that, but they don't do things physically. You may have the compute environment, right? Just getting a Python environment put together can be daunting if you've never done that before. Getting dependencies put together slow people down. Well, if you're a developer, that's not a big deal. You've done that 100 times or 1,000 times. But for someone who's never done anything in that type of environment, there's a little bit of a hurdle to overcome. And with Hugging Face, you have open source AI models. You have the data sets. You have the data collection. You have the physical movement of the robot. And I could probably come up with a few more domains here. But the point is, even though in isolation, any one of these things is not really difficult, it's such a broad range of domains and technologies that have to come together: software, machine learning, open source platforms, the physical robots. And if you don't have strength in any one of those areas, you kind of have to start from scratch and go figure that out and go do that. I think a barrier is certainly not having a breadth of understanding to help fill in blanks, because none of us have complete strength across the board. So being able to be more generalized, more generalists across the spectrum of domains that are necessary to implement these things, that can be a challenge. But at something like a hackathon, where the stated intention is to learn together, it helps overcome that, because you're offsetting your individual limitations by the herd, the group's complete capabilities. So I may be really good at the software, but someone else has done the physical robots, and someone else has a machine learning background. Well, now all of us coming together is very helpful. So I would say, with that said, we really didn't have technical hurdles that were highly problematic. It was just for the inevitability that someone would have areas where they were less strong in. We would just have to lift them up a little bit to get them where they needed to be. But that's what we're there to do.
Yeah, that's what a hackathon is all about, right? We just teamed up, we just trade off our knowledge and try to just share our knowledge and expertise to build something together. Love that, Daniel. It's just thank you for sharing your wisdom about all these robotics stuff. I'm pretty sure our listeners are now literally interested to do some holiday. Probably the only style is listing down some of their holiday projects. They're gonna try to build robots that they are gonna help use for their running their household chores or all kind of stuff. Now we have to move to this next section, which is very important as well in that AI and robotics landscape, which is ethics, safety, and social impact. And to continue with that section, I'm going to pass it over to Mac.
Thanks, Sam. Daniel, really love the conversation, the way it is going. We learned actually a lot of things. So the best part is that even I remember that, like 10, 12 years back, that when we were in college, we had to go through 1 or 2 full semester to go through, like the whole robotics course. To learn all this stuff like the robotics. And at that time, it was coming into the market. And, so if someone wants to start something, then they'll have to go through probably, like 6 months or 1 year preparation just to learn in robotics. Now, the way you explained in just to, create an account in Hugging Face and then just, like download 1 AI models and then, put 6 commands in Python and then, like you can just simply train the model like in 24 hours or 48 hours. And then, you can get that robot. So much fascinating. This is a game changing. So I don't think that technology would be a barrier anymore. I think, and someone doesn't have the money, I think it still is achievable, like, with everything. So thank you so much for sharing that. For my next segment is, as robots become more autonomous, how can we ensure their decisions remain interruptible, safe, ethically aligned with human values? This seemed like a critical challenge as we scale these systems.
It's extremely important topic. And we all should be a part of the conversation around this because there's a lot to it and our voices are important. I saw something in the last few weeks, which I think is worth repeating here. And it was a slide from a Microsoft presentation, if I remember correctly, from 1979. And it said, computers can never be held accountable. And for that reason, we must never allow them to make decisions. So when we talk about a robot being autonomous, I don't really believe that we would ever have a situation where that robot itself would be its own standalone entity that could make its own autonomous decisions. We should never allow that. Mm-hmm. What we need to keep in mind is that this is not an alien species that has found our planet and is now assimilating with our population. These are devices that we have created. These are our inventions. And because they're our inventions, we get to decide what they do. We get to decide how they think. We get to decide how they react to things. And we must remember that behind every wildly impressive autonomous robot is a decision that was made for how that robot would behave. So there's a human that's ultimately making those decisions. And if that human says, I'm going to delegate my decision-making authority to this robot, we can't simply say that human has now absolved themselves of any responsibility related to that robot's actions, because it was the human's decision to do that. So the people, the companies, those that are enabling and empowering these robots have a huge responsibility to do so in a way that does not impact our human experience in any negative way whatsoever. And if they do, they need to be responsible in the same way that they'd be responsible if they themselves as a human were doing those tasks or doing those activities. The buck has to stop at the decisions that are being made for how these behaviors happen. We can never delegate that to some seemingly autonomous device because we created those devices. They are not standalone entities and they never will be.
Great. My next question would be one of the very important and I think one of the most crucial aspect actually. So let me give you the context a little bit. So I was watching an European movie, and then there was some of the construction workers, like they were making when constructions, and they were being replaced by robots. Even though like the lawn mowing systems nowadays, I just saw that 2 years back in my office there were 10 people. They just came, and then they were just doing the lawn mowing stuff with the lawnmower. And now I think last year I saw that there is only one guy came and put some robotic stuff, and then I mean that was creating the entire lawn mowing for a couple of acres land. So there is a growing debate around AI enabled robots and job displacement. Now, what's your perspective on how we can balance innovation with social responsibility? So, in one hand, we're seeing the advancement of technology, but in other hand, that we are seeing that job displacement. So, how do you navigate this transition thoughtfully? What do you think?
This is a big conversation that has a lot of pieces to it. I think inevitably we will find that these devices are in some cases replacing human work or displacing human work. And certainly in the short term, that's bad. If you lose a job to a robot, that's a bad thing because you need that
Right.
income to be successful as an individual. And if we look at something like construction, yes, there are people who are highly trained and specialized in construction, but there's many other people who do things like construction jobs because they're easy to get. And that may mean that we're taking jobs away from people who particularly need those jobs because they have other limitations related to what they can do. So that's a bad thing, right? We can say it's bad for the people being displaced, losing opportunity. If they have to go find other jobs and they have limited skill sets, they're going to be more competitive. And that's not a good thing. So I think it's important that we are not just aware of these things, but that we have some recognition that some type of contingency is necessary to accommodate the societal disruptions that, could occur as a result of this. I don't know exactly what that answer is or what that looks like. But there's lots of examples today where we have programs for people who have lost their jobs. We have programs for people who are in dire financial straits. We want to keep people fed. We want to give them medical care. We want to do things to make sure that we don't just discard whole swaths of humanity because they're not in a good position. We hope that it's a temporary position and we find alternatives for them. So I think similarly to the way that we'll call it high risk environmental operations pay into systems that support any offset of any negative impacts that might happen if, say, an abandoned well leaks and needs to be cleaned up or something like that, we should be thinking about these types of disruptions, and companies should be involved in that in some way. What that exactly looks like and what it takes to get there, I have no idea, but I think it's wise for us to recognize that there will be displacement. Now, from a long-term perspective, jobs have changed all the time. Over the years, the nature of work is wildly different than it used to be. I like to maintain a garden. I like to get out there and grow some things, but I don't think anyone listening would prefer to give up the grocery store for a life of toil in the fields to grow our own food. It's a huge amount of work. Well, we don't have to do that anymore. And one of the reasons we don't have to do that anymore is because of the efficiencies that we've gained in the food system. Well, these are basically more efficiencies that we're seeing. And things like construction work can be very hard on the body. I personally don't know a lot of people who do construction throughout their entire life and are really happy that they did it for 60 years or something like that. It's just a really difficult job. You're out in the sun, you're lifting heavy things, you're in a dangerous situation. Those types of jobs are great for an autonomous robot that effectively can't be hurt, right? You might lose a little bit of money if it breaks, but you're not wearing out people's joints or sending them to the hospital or disfiguring them because they got caught in some machinery or something like that. So there's a lot of really good use cases where we can use these devices to do the work for us that we'd rather not do. But the benefits of that in the long term, we can't just discard everyone who's offset in the meantime. We have to recognize that there will be societal impacts, and we have to respond to that appropriately.
Love that. And adding one more thing, biggest retailer companies, they have started in their warehouse to packaging stuff to be done by robots. Then even to send those goods commodities to the customer's house also, eventually it will be by drone. So means maybe like these years are coming in future that we might not need any humans in the warehouse. Maybe they don't even drive the any trucks or any transportation cars or whatever. It will be fully through drone, and then the drone will actually deliver those commodities to our houses. So these are I mean, these are all speculations, but these are also inevitable, like in next few years. And having said my last questions in this segment, from your work in both enterprise and prototyping environments, how do you see organizations approaching these ethical considerations in their AI robotic projects?
Hmm. No, I think as a general rule, the larger the company gets, the less excited they are about small things. So, it seems unlikely to me that, say, an enterprise would adopt the robot and have a working group for that. It's not a commercial robot. It has physical limitations to the weight it can lift. The motors themselves, while they are very durable, they're not made for an industrial environment, right? So there's a limitation to what you could do with it, and as a result, I think you have large enterprises and larger companies that would say, wait for some curious enterprising individual to come up with a new robot that they then commercialize, and 5 years from now, the large enterprises will be happy to purchase those things and implement those things. As far as the kind of ethical considerations for that, it really comes down to the organization itself and what fiduciary duty that company has. If you look at traditional companies or your C corp that is publicly traded, overwhelmingly their fiduciary duty is to their shareholders, and their shareholders are going to vote at their annual meeting, and the company has an obligation to fulfill that. If
Right.
if the shareholders vote to say replace your entire workforce with robots, the employees of that company have a duty to fulfill that request, even if it's against their moral or ethical individual beliefs. So shareholders have an opportunity to influence these outcomes, and the companies themselves are not always owned or influenced by shareholders. There's other companies that structure themselves in a way that give them more flexibility and what they can do. Maybe we should be looking for companies that at least make declarations to say, we will not fully displace humans, irrationally or without due consideration, right? And who knows what that means and what the application really is, but oftentimes companies, especially large companies, are beholden to their shareholders, and that's kind of the end of their ability to act beyond that.
Love that, Daniel. And for our last segment in this episode, the future vision and innovations, I'm going to pass it over to Sam.
Thanks, Mac. Thanks, Daniel. I mean, this conversation has been shaping up really well. I would like to touch upon that, that job displacement thing. I know we kind of talked about a few examples, like warehouse worker might get replaced by robots. Like majority of the physical activities might be an opportunity for implementing robots. That's gonna probably help a human to not being involved in some sort of a high risk, high life work. But what I was thinking, yeah, I mean, obviously there might be some job displacement will happen. It would be not like a full burden if you don't think in that way. If you think that everything will be there, human will still have their job, even if robots going to come and start taking over some physical activities. But in our opinion, in some cases, it's possible that the human who's going to probably doing construction work will probably kind of like retool that, like kind of like, start learning about how to operate that robot. There'll be a possibility of like there'll be robots coming in doing the construction work, but you still need a human oversight to make sure those robots are doing their job perfectly. Maybe you got to think in that way that there might be more humans will be deployed to oversight, being the supervisor of the robots, not just doing that physical work by themselves. Maybe that's how we need to think about it. And obviously, there'll be an impact. Technology has been the most disruptive sector in the last few decades. It's always impacted the society, whether when the computer came, the mathematician, when on the parade and talking about their job loss and stuff. We've seen that in the past. So I think we are going through the transition. I just feel like we just have to think rationally and probably think a little unorthodoxly, like what we're going to do when machines going to start taking over some of our physical or even mundane tasks. I think that's probably the best way. I guess, Daniel, you already put that. So yeah, so now since we're talking about the looking ahead and future, how everything would look like in next probably a few decades. So I guess the looking ahead, like what trends or technology should we be watching in the next 5 years that will reshape the AI and robotics landscape? I mean, you talked about computer vision. It's obviously we're still using the similar kind of like computer vision models to train the AI powered models and such. But do you think there will be a huge shift in the AI robotics landscape due to the emergence of Gen AI, LLM, or there'll be something on the radar that's going to impact the human society or the way of our work in general?
Absolutely. I think something that I think about a lot is the non-human solutions. And what I mean by that are basically having robots that look nothing like a human, right? And they're able to do work that a human would otherwise do, but they're not doing it with 2 arms and 2 legs. Okay. I think maybe not a great example because there's a lot more other ones out there, but you talked about drone delivery earlier. None of us humans have wings to go flap around and deliver single packages by air, but we have this little device that can fly and carry a package. So that's one example of a non-human solution. And similarly, jobs that we've created for humans to do are environments that were designed for humans to exist within. They're tasks and workflows that were designed for humans to do. So the nature of work being human and having that change to non-human tasks and non-human work, we're going to have specialized devices that do the things that we need to be done, and they won't look or feel at all like humans. So we'll have supply chains and logistical systems that that a human couldn't step into and take over and adjust, right? Because there'll be new systems that weren't designed by humans and cannot be managed or influenced by humans. None of us is going to strap on a jetpack to deliver a package if the drones stop flying, right? So I think as a general trend, we're going to see these entirely new spaces within industry that create these new types of work, these new types of jobs that don't look anything like the human version that we've been used to for our entire existence up until today.
Yeah.
So that's one piece of it. The other piece of it is it won't be binary. We won't just have no automation and then we'll have robots. There will be this integration that you talked about where in some cases, it will be supervisors. In other cases, it will be augmented. We'll have robots that we work with to extend our capabilities and extend our ability to do things. I've seen these like mech suits that people are wearing, which increase human strength. You could imagine something like that where maybe there's a third arm that gets attached to your back and helps you, move some things behind you that, you wouldn't be able to use. So there's many different things that will be integrated into the human experience, and also the non-human experience will be an entirely new industry that will evolve as a result of all this.
Yep. So, I mean, just to sum it up, so in future, the concept of Iron Man can become a reality.
Absolutely.
Yep. Um,
I agree with that
Thanks,
too.
Daniel. Thanks for your wisdom. Pretty sure this is something our listeners will definitely resonate that. And I guess now that's probably take me to my final question of this segment is that there are listeners out there who definitely want to jump on that boat and start learning about how they can get into the field of AI and robotics. So, what would you recommend for their first steps to learn about AI and robotics? And think about that. There are some people out there who doesn't even know anything about AI, but they also want to learn about AI and robotics both in tandem. So, how would they start?
Absolutely. Well, you might by now you might be able to guess what my response is going to be. The Hugging Face Le Robot project is an unbelievable starting point. It's very approachable, it's very accessible, it's inexpensive. There's a community available. There are people that can answer your questions, and you can do literally everything from yourself, which is very rewarding. And also, Hugging Face itself for machine learning, they have all the open source models and data sets. And I think the Le Robot project is really an exceptional starting point not only for robotics, but also for machine learning and open source machine learning through Hugging Face in particular. It's the reason that I've been doing this for the last year is I haven't seen anything like this that brings together so many things in such an approachable way, yet also has a depth available for as far as you want to take it for really going far with it. So uh, go look at the Hugging Face La Robot website, join their Discord, start asking questions, order a kit, or figure out how to build it yourself, and just be curious. Show up with an absolute boatload of curiosity, and there's enough support available to figure it all out.
Thanks, Daniel. Love that the way you said the be curious. That's the main thing. As long as you put your thoughts and mind behind something, you will definitely learn about it. And for our listeners, we'll definitely share some links to the Hugging Face Robotics section in the podcast description. So please, go and check it out. So that's all from my end, and I'm gonna pass it over to Mac to wrap up this session.
Thanks, Sam. So we talked actually a lot of stuff today. So the first, we started with evaluation of AI and robotics, real world AI robotics and applications, technical foundations and challenges, ethics, safety, and social impact, future vision and innovation. So, and definitely that we also talked about like like technology is not the barrier anymore. I think someone who wants to uh, and to start working in robotics, I mean, is like just a matter of few steps. So this has been an incredible session, Daniel, and the perfect way to close out our first season. So, where can our listeners connect with you, learn more about Brainwave Collective, and potentially get involved in the hackathons and projects you are working on?
Absolutely. Love this. Very easy. Go to brainwavecollective.ai. We have easy to find link that goes to join our membership. We just opened up membership for community and also inventor and investor access as well. We'd love to have everyone be a part of that. And we also have a meetup group here in Denver that we get together with for the public events that we have as well. So even if you're not a community member, we also host some public events to learn about these things and getting involved in these things also. But yeah, you can email me directly, Daniel@brainwavecollective.ai, but just go to the website and that'll take you through everything you need.
Awesome, Daniel. Thank you so much. And that wraps our entire first season of Inside Assemble AI. From marketing to robotics, we have explored AI's transformative impact with incredible leaders implementing this technology strategically. To all our listeners, thank you for this journey. If you found value in our conversations, please subscribe, share, and join us for season 2, where we will continue cutting through the AI hype. Until then, keep innovating, but keep it strategic. Mac and Sam will be back soon. Thank you.
Thank you.